Welcome to Chemistry Online. Today we're going to talk about molarity. Now, lots of chemical reactions take place in aqueous solution. In order to do stoichiometry for these, we need to use the term molarity. Molarity simply describes as the number of moles of solute per volume of solution in liters. If you wanted to make a solution of known molarity, what you would do is use a volumetric flask. Volumetric flask is etched somewhere here on the stem with a little line that indicates an exact volume. You start off by putting a certain number of moles of solute into the flask. You then dilute so that you have exactly a known volume of your total solution, again in liters. Moles of solute, volume in liters. If we had a solution containing 3.25 grams of sodium bromide in 1250 mils of solution, what would the molarity be? What we need to do is to simply calculate the number of moles of our solute, sodium bromide, and divide it by our volume in liters. Remember that moles is simply calculated by mass divided by molar mass. If we then divide this by the volume in liters, our grams will cancel. Per mole in our denominator here will come up, and we'll be left with 0.0253 moles per liter. This is the same as 0.0253 molar, uppercase M for molar. If we dissolve 6.47 grams of sodium acetate in 1450 mils of solution, what molarity would this solution be? Once again, we're going to calculate our molarity as mass divided by molar mass. Then we're going to divide that by our volume. Mass over molar mass divided by volume. Grams cancel. Per mole comes up. 0.0544 moles per liter, or 0.544 molar. Now, another way to state this problem is something like this. We need to know what mass of sucrose we have to dissolve in 150 mils to make a solution that's 0.25 molar. Well, in order to calculate this mass in grams, we need to know how many moles of sucrose there are in 150 mils of 0.25 molar sucrose. Then we're going to multiply that by the molar mass, that is grams per mole of sucrose. So the problem would look like this. Moles of sucrose. Here we have a concentration and a volume. Concentration times volume gives us moles. All right, so this is how many moles of sucrose we have. Our grams of sucrose, we're simply going to take our moles, multiply it by our molar mass. Mole and per mole will cancel, and we're left with 13 grams. Now, there are a couple tutorials here dealing with molarity. This one's very simple. You're simply given either molarity, moles, or volume, and you have to solve for the missing parameter. Here we have moles and volume. In order to get molarity, all we have to do is divide moles by volume. In this case is 0.454 molar. Here we have molarity in moles. We're solving for volume. Volume is going to be moles divided by moles per liter. And in this case, it's 4.26 liters for our volume. Our last one here, we have a molarity. We have a volume, and we're looking for moles. Moles is going to be molarity multiplied by volume in liters. So we have to convert that, multiply it out. We have 0.365 moles. The next tutorial does the same sort of problem, except it's a word problem. There's also involved a little bit of a metric conversion. Here we want to know how many milligrams in 0.772 liters of a 1.13 molar solution of methanol. First of all, we have to calculate the number of moles. Concentration times volume gives us moles, 0.872 moles. To convert this to grams, we need the molar mass. So here's our moles, our molar mass. We have 27.9 grams. Finally, the problem wanted milligrams, so we have to multiply this by 1,000, 27,900. Finally, what volume in mils of a 1.75 molar solution of calcium nitrate would we need if we wanted a 0.0879 moles of solute? Moles divided by molarity is going to give us liters. This gives us 0.0502 liters. Convert that to mils simply by multiplying by 1,000, and we have 50.2 mils of solution.